we're gonna give another maybe a minute or so for people to join in, and then we are going to get started. Since we have a lot of ground to cover, if you need to say anything, just unmute, and then whatever you need to say, just go ahead and say it. So this is gonna be almost like an open forum, but centered on one particular slide. Then discussion and a little bit of some coding examples. So that means if you can be able to be accessible to your computer with your favorite tool, which I would recommend if possible. Like I said last time, it'd be nice to have Anaconda installed. If you don't, then you can also access online Google Colab, which is a very good tool, just almost mimicking Anaconda, and it works very well. So that's what I used for most of the code examples, which I'll be sharing here with you shortly. Okay, I'm gonna go ahead and get started, and whoever comes in, please feel free to join in, and you're welcome. So this course here is basically programming in Python. Now, programming in Python, definitely we cannot finish that within a period of, for example, 1 hour, 30 minutes. So as a result, this is actually second part of what I did previously. I believe we did that last month. And this is just to be a continuation of what we are trying to achieve. Now, the course itself is assuming quite a few things. So we assume that you have some basic knowledge of programming. Of course, basic enough at the elementary level to be able to understand, because Python is very straightforward and easy to actually understand and digest and work with. And some of the tools I would recommend, of course, you have to have like a laptop to use, which will be able to help you follow through. Now, the tool which I used here for programming, I used Google Colab. It's recommended since it comes with deep learning capabilities, and the way it works, it's very fast because it has a graphic processing unit which does not take a lot from your computer, and it has other units for like the packages for tensor processing when it comes to deep learning and the artificial intelligence part of that. Okay, so I say a regular laptop will be able to do the job, and let's go ahead and just get started. And if you have any question, please, by all means, feel free to ask.
Quick question.
You have a question?
Hey, Mr. George, this is Dennis. Thank you for doing this. Do you or John, do you guys record these meetings?
Yeah, we're going to record it. Yes, sir.
Okay, thank you.
Yes, sir. All right, so
one question. Are you going to do an overview of what you did last time, just for context?
I will share that in are you in the WhatsApp group?
Yeah, I am.
Okay, I'll reshare that in the WhatsApp group. It's in the PDF format, but I recorded it, but the recording was not great of a quality. But if you want, I can just share that with you also.
No problem. That would help just for context.
Okay, no problem. And who am I speaking with?
This is Robert again.
Okay, Robert. Also, feel free to send me your email.
Okay.
It would be great if I can I can have that. That way I can also be able to communicate with you directly.
Sounds good.
Okay. So the overview of the course, this is an introduction and of course the history, just a brief history of what Python as a programming language is. Now, then we're gonna go ahead and also introduce ourselves into data science, of course, using Python. And then we'll do a little bit of data wrangling. Now, data wrangling is basically the process of cleaning the data. Because most of the data, sometimes they come in really very loaded with a lot of undesired characters. And of course, might not be permissible or might not work the way we want it. Okay, and then also we'll do a little bit of predictive analysis on Python. Okay, and of course we'll touch a little bit of stock market, some little bit of financial analysis, meteorological data, and also email spam prevention. And then we'll also be touching about machine learning and how we can visualize the data. Okay, so like I said, the course outcome, definitely we need to be able to have some tools in place. Now, you should be able to at least install Python, and then on top of that, then you install Jupyter Notebook, which comes in Anaconda, or you can install it independently, or you can install PyCharm, or you just click on Google Colab, or you can search for Google Colab, and Google Colab will be able to pull up, especially if you have Google email. So it's going to be easy. It's almost like you're working with Google Docs. Now, we will be also able to clean the data, like I said, and then we use the analysis in machine learning and also in AI. Okay, so, and then we, of course, we go through the visualization tools and what we will be getting from those. Okay. Now, Python, it's not a very old language, but it first came into the market and it's been around since 1991. It's an interpreted, object-oriented, high-level, general-purpose programming language. Now, the design philosophy of Python basically emphasizes the readability and also the ease of use, as in the syntax, almost like learning English language. Okay, so Python has a unique way of some of the syntax. It emphasizes very much on white space and also indentation. So when we say it's a high-level language, it's high level in the sense that it focuses only on what it's going to be doing, okay, instead of how to do it. So that is where the name high-level programming language comes from. Okay. Okay. So let's see here. Okay. So Python is an interpreted language. That means the opposite of interpretation will be compiling. Now, Python will be running and converting line of code one after the other, which in real sense is a little slow compared to a compiled programming language. Okay, but of course there are tools out there which make Python compilable. So you can design a Python script and then you run it through a particular tool to be able to convert it to an executable. Now, executable like an EXE, which is going to be like machine language, and that makes it very fast. Okay. Now, Python also is freely available and makes solving computer problems almost as easy as writing one's thought, like in a recipe or in a shopping cart, a shopping list. So Python code is also very portable. It can be written once in a Mac environment, and then the same code without necessarily changing a lot of things. Sometimes depends, but mostly it will not even need you to change anything for the same code to run in Windows or Linux environment. So that makes it portable. Okay. All right. So okay, Python is, like I said, it's general purpose. It can be used on any modern computer operating system, Mac, Linux, or Windows. Those are the predominant OS available. Python can also be used for processing text, numbers, images. We use it for scientific data analysis, and we can even use it for game programming and even in the web development. So it's basically all-purpose. That means it can be used in almost anything you can imagine. Okay. Now, Python is also heavily used by Google, okay, in its search engine. Like when we Google stuff, basically the backend has some way of Python libraries incorporated in those. And Python is also used in video sharing website, YouTube. NASA uses Python, and even New York Stock Exchange uses Python. And this just to mention just a few of those other companies using it. So that tells you how marketable this language has come, and also some of the opportunities it can present to you or to me as a person, especially based on what you want to do, like in terms of if you want to move into this space of programming with Python. Okay. Now, because of the user friendliness of Python, of course, we've seen how it's being adopted by so many other companies. Many major projects, because of the ease of use, and it's very extensible. Python has a lot of libraries, it has a lot of packages which enable us to basically use it almost out of the box. So that makes it being called like batteries included language. It's almost good to go, so long as you can know what you really need to know to be able to start using it. So most of the code are not very complicated to understand, but one thing you have to be able to import. Before you import the library, you have to be able to, first of all, install it. So Python, you install, and then once you install Python, then you should be able to import the library you want to use so that you can start working with it. So here shortly, you'll be able to see what we are going to do with the syntax in as far as importation goes. Okay. So Python, again, among so many other uses, like in game programming, in data, like in game programming or in data science, in web development and all that, one of the main things which Python is being used predominantly now is in data science. Okay. Now, data science is an interdisciplinary field which uses scientific methods, okay, processes, algorithms, and systems to extract knowledge, okay, and insights from structural and unstructured data to use for data mining, for deep learning, for big data, for machine learning and artificial intelligence. Of course, that's a mouthful, but some of them are related, but that gives you the extent of how much we can use Python to help us. So, of course, when we talk of deep learning, we're talking of the math and the statistics involved. We combine that with the computer science and information technology, okay? And then, of course, the business logic and the knowledge of that same business and the domain in the business help us all combine together to come up with how best we can consume the data, okay? How we can predict certain, say, for example, stock market prices, or how we can possibly be able to predict the weather, okay? Help us also in data, as in be able to, for example, in the sense of NASA, they use that data for image processing, because Python has really become very a tool to go for when it comes to a lot of these things, and it's very easy also to understand and use. So we'll see some of the examples as we go along. Okay. So that's the same summarized concept of what we just saw. So they said, like computer science, talk of programming, math and statistics, and then communication. Okay. So a little bit of math is required, but not very much. So, and I'm assuming a little bit of programming for most of us here will be able to understand what we can do with what we are going to do. Okay. So the data science part of it will provide tools for data analysis, statistical analysis. It also provides the fundamentals of data analysis. Okay, some of the statistical methods used in data analysis are like the Bayesian method. Okay, that's really hard for me to say. And then the regression and clustering. So for those people who probably did a little bit of that statistics, might have learned about this person with the methods. For example, when we talk of like you toss a coin, and then you expect the coin either to land on the head or the tail. The chances of it landing on the head or the tail will be 50-50. So that in itself is a method which was basically introduced by Bayesian, or the Bay, the guy's name being used in that. Okay. So that's probably just another repetition of the same PowerPoint. So don't worry about it. And then we'll go to the next one. Okay. Now, one of the major reasons why Python features more in data science, machine learning, and AI, like we say, it's very easy to learn and understand. It has a lot of libraries, packages which help us support the implementation of data science, machine learning, and AI. Now, among the libraries which we are going to be using and talk about will be one, Pandas. Okay. Pandas stands for Python Data Analysis Library. Okay. It's an open source Python package that provides high performance, easy to use data structure and data analysis tools for the labeling of data in Python programming language. Okay. Now, before we use Panda, we have to be able to install it. Before we use it, we have to be able to import it. Okay. Now, I don't know if you can see this, but this is Pandas in use. So I'm gonna go ahead and share with you a screenshot of what we'll be able to do with that. Okay, so okay, I'm gonna type some of the commands here. First of all, we are assuming that we imported Pandas. So after the importation, we just go ahead and no, we assume that we installed it. So right now we are going to import Pandas. So we import Pandas as, and then we just give it a name, PD, short for Panda. And then we click, when you're working with this is Colab. When you're working with that, it's gonna be almost close to working with Notebook. Okay, Jupyter Notebook. So when you click on that, Colab basically run. So when it runs, it comes back, and if I don't see anything on the screen, that means we are good to go. And then the next thing, I can go ahead and just press enter, and that will give me another screen. I mean, another space to work. Now I'm gonna go ahead and import NumPy. Now I will talk about NumPy in like 1 or 2 slides below. That will be able to give you an understanding of what NumPy is all about. So we go ahead and say NumPy import as NP. Okay. And then once we do that, then we go ahead and declare a variable. The variable could be anything. So we just say, so long as it's good to go. So we can say df, okay? And then the df, now we say PD, remember was that PD up there. That now we bring it down, and then we say, now we want to use that PD to read a method. So we say read for us as a method which is going to be CSV. Okay. Now, assuming that we are going to read a file which is already existing. Now, for me, in here, I had to import. Okay, I imported a file which I knew I was going to use, and the file's name. Okay, let me see if I still have it. Okay, let me see if I can get it here. Okay. The disadvantage we have with the Colab, after some time, you get rid of your imports. So that's what it did to me. And that's fine, because they try to control clutter. So we go here, and then we basically say we'd like to be able to read this one in there. Okay, so that's a CSV file for Flickr images, and that I got that online, so I'm just using it for demonstration. Okay. Okay. You have to make sure that you get that spelling right. Otherwise, you'll be scratching your head thinking maybe you did something wrong somewhere. So assuming this is good to go, then we go ahead and go to the next line. The next line, we are going to read the head. So we say df.head is basically almost saying, go ahead and get this file, but we only need the header part of it. Okay. So when we say that, that header will be the header will be, sorry. Okay, the header will be a method. Then all we have to do here, we just go ahead and say, we click. So whatever we imported, right, here, is actually being read by pandas, okay? If you look what we just got on the screen, is the same thing we have out there in the slide, okay? So that's how pandas works. I'm not gonna go deeper into it for now, but we're gonna go ahead and go to the next one. But I would request, keep this in mind. So this will come very handy as you go along, okay? All right, so now the next part will be, okay. So we read that already. Then we come back here. That's the blown up part of it. So the same thing. Okay, now remember we used NumPy, okay? This one right here. If you go in, if you go back to this line of code, if you look at number 2, line number 2, that's the same library. So now we are introducing NumPy. Now NumPy is a general purpose array processing, okay, package. It provides high performance multidimensional array objects and tools to work with arrays in programming. Now in this case, going to be in Python programming. Now an array could be an array of people, array of objects, array of numbers, array of, let's say, addresses. So all can be processed using NumPy. Now NumPy is quite efficient, and it can also work with multi-dimensional arrays, okay? Now this is a picture of what an array would be, okay? If you say, for example, you have blocks, you can, okay? You can now pile blocks, and then you give those blocks numbers. Now that's an array of blocks. You can be having this, could be like in a situation whereby you have, for example, mailboxes, okay? That's a very good example of an array, okay? Okay, so how to use NumPy now. NumPy will be, I'm gonna go ahead and also create another instance of how we can do that. So I'm gonna go ahead and say, we open a new notebook, okay? And then we code that. So for a very simple dimension array, we just say, we just import NumPy, okay? Num as in numbers, Py as in Python. So most of these libraries, some of them, they have very funny names. It depends on whatever or whoever came up with the name. So it really does not matter. So here we import it. Once we import, let's go ahead and run. Now to run, we test if we have it available ready, installed in Colab or installed in your case, it could be you're using Jupyter Notebook. So if I run it, if we don't get any error, then that means we are good to go. That means it's already been installed. So once we have it installed, we import it, then we just declare an array. So we can say array of NP. Remember the NP, and then say dot array. Okay. So in that array, we have to be able to use the square brackets. Okay, we say 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then in Python, just like in so many programming languages, we just go ahead and print. Now, go ahead and print for us array. Okay. Now, when you print the array, you run it. So it's basically taking us, telling us what we just put in there. Okay, that's all we needed. That's the array. Then, if we wanted to do multi-dimensional array, then I would probably say, let's go ahead and do the same. But this time around, okay, we're gonna subdivide this into several arrays within an array. To say that one, and then that one. That's a regular bracket. And then this one, and then put another one right there, okay? So when you're running this one, it's gonna be different from running the top one. So let's go ahead and run the bottom one. Comes back with the same thing, but just a multi-dimensional array, okay? That's how NumPy works, okay? I hope nobody's sleeping, right? I mean, if you have any questions, please.
We're awake. We're
Oh,
awake
that's
and
good,
watching and listening.
Hope you guys are enjoying this the way I do. Okay, so the next thing, which is going to be
Sorry,
our
George.
point of study here. You have a question?
Yes, a quick one on the second array. Can you explain a real world scenario you're trying to model here?
Explain a real world scenario.
Yeah, just so it makes sense.
Okay. So let me go back all the way to the array we had before, right?
You can use addresses as you gave us an example earlier.
Yeah. So you see this is like a single array, right?
Mhm.
Okay. Now imagine you have several blocks piled. So from 1, 2, 3, 4, 5, 6 up to 13. Then behind this, we could be having 14, 15 up to 26. Behind that, we'll be having 27, 28 up to the next number. Those will be multi-dimensional array. You hear?
Mhm.
Can,
I can hear you. Go ahead.
huh?
Continue.
Okay. Now we have, this is a single, whatever you see on the screen right now is a single array.
Mhm.
Now we pile them one after the other, one behind this one, the next one behind this one. Those will be multi-dimensional array. Okay.
Mhm. Okay.
So if you look here, array in programming, in most of the programming languages will start, we have to index them. So the index of array number 1, okay, will be 0.
Mhm.
Index of array number 2 will be 1.
Mhm.
3 will be 2. Say if that was 4, it will be the next one. So in subsequent numbers, like in sequence, right?
Right.
So if we had several of those arrays, to be able to get to a particular address of one particular array, you'll have to know its index. So if you're looking for array number 1, you'll be looking for index 0.
Mhm.
If you're looking for array number 13, you'll be looking for index 12.
Right.
Now, if you pile them one after the other, this could be like, it could be a building, okay? From the ground floor going all the way up. Each and every floor will be an array. And within a floor, there'll be several rooms.
Mhm.
Maybe room number, let's say floor number 12 could be having a company, and that company could be having cubicles.
Mhm.
Now, if it's floor number 12, it's going to be 0, 11.
Mhm.
Okay. In that floor number 12, there'll be cubicles. Those cubicles will also be arrays within an array. So there will
Okay.
be cubicles within number 12. Then they'll also start with the index of 0. If there are 20 cubicles, we'll have index of 0, 1, 9 to be the last one.
Mhm. With reference to 12.
Say again?
With reference to 12.
Yes.
Okay, got you.
Is that making any sense?
Yeah, making some sense.
I-
Continue. I didn't mean to distract you. Just go ahead. Sorry.
Okay, man, don't worry about it. I mean, if you can't get it, why are we here anyway? So whenever you have a question, it's okay. Okay, so we did the multidimensional array, okay, and then that came up. Now we know what NumPy works. I mean, we know how NumPy works, especially when we did NumPy and pandas the first time. Now we did that before we learned what NumPy is. But basically, NumPy is just numbers in Python. That's what they name it. Now we have SciPy. SciPy is basically scientific simulations or scientific library in Python. Now this builds on the NumPy array objects and is part of the stack, which includes tools like matplot library, which we will see shortly, and also includes pandas and SciPy. Like this SciPy could be like symbol in Python, for example. Now the library contains modules for efficient mathematical routines like linear algebra, interpolation, optimization, integration, and statistics. It makes a lot of use of NumPy for it to achieve what it needs to achieve. Okay. Okay, so how do we make that work? How do we use NumPy? Now, the way we use NumPy is I'm gonna go ahead and come out with another window so we can also follow through with that. Okay. Okay. Remember, before you use it, you have to install it. Before you use it, you also have to import it. So we're gonna do the same here. Now remember, we touched on pandas. We just touched on NumPy. Now we are going to use SciPy, but SciPy cannot work in this case without importing NumPy. So we say, go ahead and import NumPy, okay, as NP. Okay, and then we say from SciPy, okay, import input output as SIO. Now some of this like SIO, NP, those will really depend on what you want to call it. Does not matter. But this one, IO means input output. Okay. Then now we are going to go ahead and declare an array as a variable. And then we use NP, that NP as a NumPy, and then we say once. Now once, this is going to be a method for NumPy. So 0, 4, okay? And then once we do that, we go ahead and say SIO, which is the SciPy we just used. We're gonna call it, an object known as SaveMat, which is available in SciPy. Okay, so say example dot mat. Okay. Okay. So say array. Okay. And then we say now we want to see the data coming out from there. This will be an error, so you have to have one dot there. Main data. Then we load mat. That's part of the SciPy JSON object. It's a method in method part of the SciPy. So we come here, then we say example dot mat. Go ahead and put structure as the code is true. Okay. So we're gonna go ahead and retrieve that. So when we retrieve that, let's go ahead and run and see what it comes up with. Okay. I have too many sessions running, so I'm gonna go ahead and delete some. Can you make that? Okay. Okay, so we have an error. Yeah, that's very interesting part, man. See if we can use oh, sorry, I got it. Okay, should be once, not one. So we'll try again here.
Hey, George, look on the very last line.
Second.
Data. Data has two T's on the bottom. Instead of one.
Say one more time.
Data has two T's instead of one.
Oh yeah, right. Thank you. All right, thank you, man. All right. Is he getting that? So, I don't know what I did there, but it came out right the first time. Okay. Yeah. Okay, if it doesn't work, I'll have to go on and come back to it.
George, I have a question.
Yes, sir.
Go back to that line where it's SIO.SaveMat. look on the last string right there when it says AR.
Mm-hmm.
The difference, yeah, you see that?
Right. Thank you.
And then take out the last one. The last what do you call it? Go to your right. Tab over to your right. No. Okay. The extra
Yeah,
apostrophe. There you go.
that's right. Thank you. That was good. Thanks, man. Okay,
You know,
this one works. All right. So this is just an example of how SciPy would be able to work, but it has to work with NumPy in this case. So we get an array, like multi-dimensional array of several, this is 4 by 4. We can say, how about multi-dimensional array of 10 by 4? Okay, can just change the dimension, then see how it works. Okay, those are ones, right? Let's try, is there anything like twos? Maybe not, maybe not. So ones will work for us, and we can get multi-dimensional array. We can say 10 by 20. Okay, so that's what we get from there. Now, our next library will be Matplot library. This is for like math as in math, plot as in plotting, and then library. So this is the name. So this is a plotting library from Python that provides an object-oriented API for embedding plots into applications. It is a close resemblance to MATLAB. Those people who probably did maybe some engineering work, a little bit of detailed math, maybe in college, this what we call MATLAB. We use it a lot in engineering classes. So it can do histograms, batch plots, scatter plots, area plots, pie plots. Can also depict a wide range of visualization. Okay. So this is the implementation I came up with. Okay. Hopefully this would not take too long. Okay. So come here. Okay. All right. So we say from Matplot library, we import Py. We talk about PyPlot. PyPlot is just Python for plotting. Okay. As PLT. Okay. And then we want to do the same, but this time I'm gonna say that will be for just for styling. So just for styling, make the style look beautiful. And then we use a style to use the gplot. Gplot is also, ggplot is also another library. Some of these we will not be able to mention, like talk about them one by one, but when you get into the field, sometimes one will be better used in what you're trying to do than the other. So that will be more or less on a personal reference level, like what personal preference level, what you prefer compared to what the work you want to do with it. So we say 5, 8, 10. I'll copy that. And then I say maybe 12. Okay. 16. Okay. So, yeah. I have a lot of screens, so sometimes I get confused. Okay, we'll come back here. Then you say PLT bar, for example, X, Y, realign. We skipped something else, so we want to see if it can work without that. Center.
So George, you probably want to make the second X to be a Y. On the data, yeah.
All right, that's a good catch. All right, so let's assume we want to run this right now. We just want to plot it, okay? Without getting the second part of it. So we just want to plot using that. And then we want to show. Of course, you cannot visualize it until you show it. Say, let's see, PLT, let's show, call that method. Let's see what it does. Yeah, my choice was terribly this, I like them. Input. So very simple mistakes catch up with me here, especially when I copy and paste. But I'm very particular on the spacing, the indentation. Okay, PLT. Start. Okay, then we go back in here.
The last two lines, they're indented. You
Oh
put
yeah,
them back.
indentation. Okay. Okay. See, that doesn't look very nice. So let's say we add something here. So that's another axis. So we say, I don't name that a 6. Maybe that's 11. Maybe that's 12. Maybe 6 here. Those are the numbers can probably just run down with 7 and maybe 15. Once we do that, then we have to have the second bar. Okay. Second bar will be, have to copy from there. Okay. And then just say Y2, and then color. We want to put the color. G for green. Maybe alignment would say center, which is good. And then let's run that. And then, of course, you can tell that even if we don't add the epic as the title or the XY axis, the X and the Y axis labeling, you can always do those. So for us, for now, we just want to see, okay. Okay, let's try again. Okay, I need some errors, but that's good.
So the second set of variables, the x, y, the second x and y, maybe you change it to x2 and y2. No, the one before that.
Mhm.
If you go back up,
Which one?
6, 8, 11, the first x.
Oh, yeah.
Yeah. Y2 and x2. Yeah.
Okay, cool, man, thanks. All right, so you see
Yeah.
what's happening there? Okay, that's for now, for here. Okay, that's how Matplot library works. Then, of course, we go to the next one. Okay, so Seaborn. Seaborn is also for data visualization. It's a library. It's based on Matplot library. It provides a high-level interface for drawing attractive and informative statistical graphs. It's an extension of Matplot library's advanced features. Okay, so you'll probably be able to look at how it does it here. Might take a lot of time, but let's see. I think I did those somewhere here. Maybe I should be able to share that screenshot. All right. So you see, like the first one, we import NumPy, and then we import pandas, and then we import Matplot library. Okay, and then we use Seaborn. Then we try to set the context as in what you do when you're just about to draft the graph. Okay. So for this one, I think it's too long. So since we'll be sharing the notes and we might be running almost out of time, pretty soon I'll go ahead and just brush pretty quick. Then maybe if somebody has a particular question, then just feel free to ask. Okay, so we imported all the libraries up at the top, and then we declared a variable, and then we went ahead and load the data into that variable, and then we print it out. So that printout is what we'll come up with here. Whatever we printed out from the data we imported, we came up with okay, this some kind of very basic data from some data set. Okay, it's from some Titanic. I'm not really sure for what, but we loaded that and then we consumed it. And then we say the gender, male and female. Okay, the name of, I think this probably, I would assume maybe now the people who were in the Titanic. I'm not really sure, but this is the data I got out there. And then once we get the data, we only print the 5 rows and the 15 columns just to give us an idea. Okay, and then we see the number of this female and male, and then they survived. I believe this is the name of the people who survived. I don't know if anybody survived the Titanic. And then they came up with now Seaborn is able to print for us the graph. Okay, so how do we get that graph to be printed? Now, when you look back, you see we grouped uh, the number of these people by sex or the gender in Titanic, and then some of them survived. So we go by whoever survived, and then we print it out. So again, you have to use the method, the short method, to be able to get that going. Okay, so that's for the seaborn. Okay. Now we have one which is this is a Google's baby, so we call it the Science Kit Learning Library, which Google came up with during one of their summer camp code project. It's very robust. It's a very good machine learning library for Python. It features machine learning algorithms, okay, which are listed here. Among them, we have k-means clustering. We have the random forests, spectral clustering, mean shift, SVMs, okay, cross-validation and more. So NumPy and SciPy and related scientific operations are supported by Science Kit Learning Library, okay? So you see, there's a lot of relationship between these libraries. See, one depend on the other. Okay, as you go along, you see a lot of dependency relationship. So the next one is basically how do we use it? Okay, so I was able to run this example. Okay, so we import the science kit, we call it sklearn, then we go the data sets and then import the digits. So basically go back down there and then you say with the importation of those digits, we want to print, okay? We want to print that data. Then we say, okay, we want to be able to label those and then we say, go get the image. So then we say, go in the next one, go ahead and import NumPy. Okay, and then import Matplotlib library. And then we are going to go ahead and get the figure size of the printout. Okay, so whatever we're going to get to be printed out on the screen, we basically want to get it, and this could be in pixels. Okay, so the height and the width pixels. And then go back in there, and of course we have the loop. Okay, and then we loop through what we bring over. Okay, so we have, remember when we talked about the indexes and also the arrays? So we want to be able to print this from like 1, 2, 3, 4, up to 5, but we have to start with index 0. Okay. Now this, we are going to give it the font size, and then these are the labels which we are going to name those printouts. Okay, so when we ran that SciPy, this as an example, we came out with this screenshot. Now, as you can see, this is 1, 2, 3, 4, 5. Now remember, this science kit is used for machine learning. So that means we can use that data to train. We can use the data after we clean it for training purposes, in the sense that we are going to train something to be able to do something in the future. Say we can use 10 years of rainfall data. Once we bring it in, we clean it, and then we train it so that we can be able to predict the weather tomorrow, or we can even predict the weather of next month based on the historical data. So scikit-learn, in this case, we can use it to do the same. Now, I could not cover the whole thing in this. So what I did, I basically referenced this one for further reading. Now, when I share this with you all, you'll be able to get this out there. But for the sake of this particular data, just for illustration, we use this one for splitting the data and then training and testing the data sets. Okay. It might not be something which we can cover within a short period, but for an example of how Scikit data works, it fits the budget. Okay. All right, so we have another one. Now, this other library is Keras. Now, Keras is a TensorFlow high-level API for building and training deep neural network code. It is an open source neural network library in Python. Okay, with Keras, that's called modeling. What works very well with images, text, and a lot of easier to simplified in deep learning. Okay, now Keras, we just mentioned, is TensorFlow's high-level API. Now, what is TensorFlow? Now, for TensorFlow, this is an AI library, like artificial intelligence library that helps developers to create large-scale neural networks with many years, with many layers of using data flow graphs. Okay, it also facilitates the building of deep learning models. Okay, and push the state-of-the-art in ML, which is machine learning, and AI, and allow easy deployment of machine learning powered applications. Now you see, like in our cell phones, we have quite a number of tools which we might not even be able to tell for sure that they already have AI in them. Some of those AIs might be relying on something like TensorFlow or Keras. They collect data. They basically bring that data together to help them make a decision based on, say, your shopping habits or based on your driving. Okay, so you find that the insurance company could be using that, or they might say, hey, we would like to give you a device you plug into your car so that we can give you discounts on your insurance based on how you drive. So they'll be collecting that data, and the data will be helping them to determine how you drive to be able to get automatic discounts. If you're maybe you're a rough driver, then you might just get that insurance premium be raised for your cell phone, for your let's say your shopping habits. That also some data which can also be used. And of course, we know lately with COVID, we talk of some kind of system which might be able to detect and get that data based on where you go for shopping, and then be able to read, say, for example, your temperature, and read the facial recognition part of it, and then be able to use that data for. So Nick, can you mute? Yeah. All right. So another thing which we need to talk about here will be okay. 1 second here. Okay. Okay, our next one will be another library which we call it Statistics Models Library. So Stats Model, this is a Python answer to R programming language for conducting statistical tests and statistical data. Okay, so this is Stats Model is a Python package that provides easy computation for descriptive statistics. For example, think of like New York Stock Exchange. Okay, the kind of data they generate on a daily basis that has to be summarized somehow. And that would be somewhere where stats model will be falling in. So we get the stats for today, and then the system will be able to take that in and then process it to be able to determine, for example, particular stock. Say it could be for Amazon, maybe it could be for Facebook, and could be for whatever reason they want to use it for. So this will be a good way of getting that data come in, and then be able to compute it and get the description. We animate, and then we also visualize it for statistical modeling and also for future predictions based on the historical data. Okay. Okay, so this is that's going to be the code sample of the stats model. So we import NumPy, and then we also import pandas before we import stats model. And then we go ahead and use the matplot library to plot. And then we use the stats model sandbox. That's, I believe, something to do with the regression. And then once we do that, then we go ahead and do the import. Okay, this is the prediction standard. So there's a lot of libraries in this which they can use and be able to model based on what they want to come up with. So what I did that importation, and then we ran it. Then by running it, we were able to come up with this particular data, okay, based on the data set. And then, of course, some of them, I'm not really sure what they are, but you can see that this is a probability and statistics, okay? And then it could be the likelihood, and could be for residual modeling, and whatever they wanted to come up with. And then based on this one, we went ahead and got that. So that draws a plot to compare the true relationship, okay, we have in the prediction, okay? So the confidence interval around the predictions are built using the predictive standard command, which we saw in here, okay? Let me go back here, okay, which is right in here. So they call it ordinary least squares, OLS estimation. So based on the field we are in, this might not even be relevant to us, but it can only be relevant if, say, for example, you know what you want and you feed it in the system. Now you use a library. Basically, the library is going to give you an idea of what you need to do to be able to come up with what you want. Okay. All right. So that's how we use it, and that's what we do with that. Of course, after we do that, then we plot it. And during the plotting, this is what we came up with. Now, for those people who will be interested, this will be something you can look further into. Okay, let's see. Okay, and then just down below there, there'll be a reference so we can see some examples. Okay, if you're really into statistics, that probably might be helping you a lot than some of us who are just basically not in there. Okay, so we have another library. Okay, we're almost done with the library. So this is a graph plotting library for Python. Okay, users can import, copy, paste, or you can stream data into the plotly library. Okay, that data is to be analyzed, visualized, can plot basic charts, statistical charts, and scientific charts. Okay, based on the field you're in. If you're in security, this could probably be something good. You capture the data as they come in, you basically look at it, and then this system with proper design will be able to plot like what needs to be looked at in terms of the security, what really need to be avoided based on, say, for example, if you have a scanner and the scanner could be like, you basically scanning the ports in a network environment. You know, for example, those who are in security, there are certain ports we know which are not very, very friendly. For example, port 21, FTP, maybe could be a port 25 for the email. So those are some of the things you'll be looking at. And if you had, let's say, the set application in a good way, then you'll be scanning specific ports. Okay. And you say the very unsecure ports, what do you need to do? So that probably some data which you can share with the higher ups or share with the developers so that they know exactly what they need to do next time, or share with the network admin if we need to have some kind of setting report on a particular, say, firewall. Okay. So when we do that, we get the data as they come in, then we are able to plot. So this is just for plotting. Okay. So if you see that, that's probably the same data we use, but this time around, we just use it for different kind of plotting. So basically, we are concentrating on the pie plot and what it can come up with. Okay. All right. So okay. Now, one of my favorites, other than pandas, is Beautiful Soup. It's a Python library for pulling data out of HTML and XML files. It works with your favorite with the favorite parser to provide idiomatic ways of navigating. Now this one we probably want to look at how it does it. So here is how it gets it. Now you can, when it comes to scraping a website, you probably want to be very careful. You don't want to scrape just any website. Some of them might have very negative ramifications, and somebody might get back to you, and you might be answerable. So many of those. So, for example, if you are say a news, let's say a newspaper company, you do a lot of your news online, you can use Beautiful Soup to go to some of the major websites, say New York Times, Washington Post, maybe Huffington Post, and then they come back and give just specifics from those, and then you can actually, with a good scripting, you can come up with a solution to how you get your news and then read them. Okay. So here we import Beautiful Soup, okay, as BS form. Then we import the URL. URL is a unique resource locator library, and we use request. Request is a Python way of consuming APIs. So we use a request, and then whatever we bring back, we keep them in the source variable. So library, URL library.request whatever we want to open, this one, URL open, so we open that URL. So let me go ahead and just run this one real quick, if we could. Okay. I did this here. If we run that, then we're gonna get this solution. So we run it again. That comes up. Okay. And then if you run this one, you're gonna get that. You run that one, you're gonna get this one. Then you run that one, you get those. Then at the end of the day, you can just say, now I would like to just go get everything and then bring them back and then use some other library to clean it up. And then you can create your own, say for example, website and then post it using somebody's data. For example, you can go to, let's say, you go out there, you grab some of the data for different states on COVID cases, the death, the survival rate, and then you bring it and then you create your own dashboard. That's a typical example of how you can use a beautiful soup. Okay. So okay, let's see here. Okay, that is the same thing. Okay, so that goes for all the libraries. Now, all these libraries we use them in machine learning. Okay, makes use of a whole series of procedures and algorithms which basically analyze the data in order to recognize patterns, okay, clusters, trends, and then extract useful information for data analysis in an automated way. Okay, machine learning or AI can use raw data from biology, physics, insurance company, finance, material testing, statistics, or on population or economics. So this is not only in IT, it could be in other industries too. Okay. Now, when we get that data, what do we do with it? Now, this aspect of what we call a data wrangling, which refers to the process of gathering, selecting and transforming data to help answer any analytical questions. Data wrangling is also known as data cleaning or munging. It's widely documented that data wrangling costs anywhere between 80 to 70% of data scientists' time just to clean it. And you only use 20 to 30% for exploration and modeling. So you can imagine how that cleaning really needs a lot of attention. Okay. Now, the methods we use for cleaning are many. Now, among those we measure, when it comes in, of course, you have to analyze it. Some of the values might be inconsistent, some might be missing, okay? Malformed records, okay? And just basically anything could be in there. If it's like a network log, some network logs might just not be very consistent with what you're looking for. So you want to drop this. Some of them might be missing, you want to fill them in, okay? So we can drop unnecessary columns in a data frame, can change the index of a data frame, or we can use string methods to clean columns. And those will always work together with Panda, NumPy. Okay, so Panda, NumPy libraries, those will work together with some of this, like data frames and string methods. Okay, so we use, for example, data frame to apply a map function to clean the entire data set. Okay, renaming columns for more recognizable set of labels, and we skip unnecessary rows in the CSV. So it could be a CSV, it could be a spreadsheet, as in Excel spreadsheet, and it could be a text file. Okay. And you can imagine, say, for example, during the election, for example, in my country, You always have a lot of that back and forth. So some of these tools come very handy when you have to do the analysis. Okay, so you remember where we actually read in data of use a CSV file. We came up with that. So that's an example of wrangling. So say, for example, only here, addition statement. You might be good, but if it's full of non-wording, then you might need to clean that up. So that could be part of the data wrangling. Also, say, for example, you want to drop some of the fields. Okay, these are field: identify, edition, place, date of publication, and that. You can drop those. Now, there are special methods or functions which you can use to do that. For example, to drop undesirable, we can drop edition, corporation, and all those from the header of what we just saw right here. Yeah? We can drop some of this to make it more sensible. Okay, once you drop it, you can use either this method to drop and replace, or you can use this one to drop. And all this will be available for your notes and also for you to practice. And I really encourage if you could do that, because that would be a good way of actually engaging with Python. Just like any other language, you'll have to speak it by speaking it, or you have to learn it by speaking it. So this is what we came up with here. Remember, now we went ahead and dropped some of the items. So it said drop edition statement, drop corporate author, and then drop all that. Once we did that, now I believe I came up with, I'm not really sure if I can get this to come up, because it could be a dead link now. Okay, I'll see if we can get that coming. So, okay, once we did that, then we went to the next one. Okay, so once we do the data wrangling, we did the cleaning, getting the data from various sources, of course, come in, piece them together, clean them. You want to keep them somewhere all together, eliminating the errors, missing elements, and all that. That's still part of the data wrangling. Takes up to 70 or 80% of your time. Okay, so if you did good in, say, getting the stock market data in and you cleaned it, then you should be able to use it for predictive analysis. Because if it's clean, then you should be able to get something reasonable and predictable coming from it. If it's full of errors, then it might give you false positives. And that will not be very good for whatever you want to do. Okay. Now in stock market, for example, we divide that into two parts. Okay. We have the fundamental analysis, and then we have the technical analysis. The fundamentals involved in analyzing of company's future profitability based on its current business environment and financial performance to help predict future profitability. Now that's good, but our main aim here is to do the technical analysis on which involves or includes reading the charts, using statistical figures to identify the trends in the market. Okay, which in turn help predict future trends based on his historical and past data. Okay, and of course this is time series, which is an important role in data analysis. This is just definition. Time series analysis, specialized branch of statistics. Use it extensively in economics, like econometrics, operations and research. Okay, and also in data and science, or in analytics and data science. Okay. Now, whether system is static or dynamic depends on which time horizon you choose. The time series analysis has three goals: forecasting, which is predicting; you do the modeling, which is like visualizing, put them together, make like a model, okay, and then you apply it in real life. Of course, we have to characterize it, okay, so we categorize it. Our focus on this series is just the technical part. Okay. All right, there are two ways to predict stock market. We do the support vector regression, and then we do the linear regression. Now, SVR, like the support vector regression, is type of support which is supervised learning algorithm with analysis data for regression analysis. It was first, the coin was first coined by Christopher Burgess. I believe that was 1996. Now the cost function for building a model for SVR ignores training data close to the prediction model. So the model produced depends only on a subset of the training data. Okay. So I mean, it's not easy to predict, but your prediction will pretty much rely on how clean your data is, what source the data coming from. Okay. If that data is not corrupted or for some reason is not accurate, then that will affect the outcome, either positively or negatively. So that will not be very good to rely on something which is already contaminated. Okay. Now the linear regression model the relationship between dependent variables and one or more independent variables. Now this method is simpler to implement, and that's probably what they normally use than the SVR. Okay, it's used for predicting numerical values. The method is prone to overfitting and cannot be used where there's nonlinear relationship between dependent and independent. So this linear regression is more easier to use than the support vector regression. Okay. Now we have the data source cleaning, securing, and using it. Okay. Of course, we talked about web scraping, which is huge. When you don't have the data, but you need to come up with a dashboard, you probably want to rely on some real serious data, like Johns Hopkins data, or you go to Google, you get some really serious data. That's how you do it. Now, there's a website we use, for example, Kaggle, I believe Kaggle, and then World, data.world. They have some of the data available. One time I went to one of the websites, I think for the election in Kenya, and I was able to get data from there, but some of them are, to me, a little questionable. So, so I basically just abandoned that one. So I was able to get the data from my end of the line, which you probably want to check them out. It's I believe I shared this one with you. Okay. Data.world, and that once you punch it in, it's going to come up with you probably want to register so you can get to use it. You can also use Kaggle. Kaggle is really very well known for data sets. If you really want to get into serious Python programming, there's a lot of good people out there and examples that you can also utilize. So in this case, web scraping is huge, you know, and most of the people use that, and I would really encourage you to try that too. Okay. So I did some stock analysis here. Not really complete, but I have a link which I shared down here. Gives you everything I did. Now I had to import some of the libraries. Now there's a new library which they call Candle. Candle library, it indexes millions of numerical data sets across the world and extras. Okay, its most recent version is available here. So let me see if I can. Okay, let me see if I can get that here. Okay, so this is what I did. I basically ran the Quandl library, and then I did NumPy, and then scikit-learn, and then it gave me the stocks for Amazon from 1997. Okay, this is a long one, so I only needed like the head. I only did like 5, but this can go, let's say you want to get from 2011 to 2011, I mean 2011 to 2020, maybe end of June. You can do that. Okay, so this came up, and then able to see some of the stocks, the volume of trade, the low, the high. Okay, and then able to get, okay, this is the data right here. And then we just print the first 5 rows, which is there. And then now only the data for the adjusted close column. So we are able to only get the year, the date, and then we only get the adjusted close. Now, remember, you can do your part 2. If you don't want that, you can do, let's say, adjusted low, or you can do the adjusted volume, or you can just do this one and then comma, you do low or high. Okay, so that is how you can deal with, say, historical data. Okay, if you have AI knowledge good enough under your belt, you should be able to predict the future trend of, say, Amazon stock, and maybe you can make a decision based on that. Or you can even create your own tool. If your tool is working real good, then who knows, you might just be able to sell it to somebody. So this is what they do, okay? So we went back in, and then we did a little bit of cleaning. Now we came up with all this, okay? Of course, we do the prediction, okay? This is the predicted. We change that to adjustable cost, and then we print it out. And then this is all commented, okay? Everything is commented, like as in documented. So if somebody was following that, you just follow along with the coding, and they should be able to get to see what it's doing. Okay, that's for the stock and the prediction. But I have more, which I'll share the link, which I'll be able to share with you. The next one will be the email spam detector or the classifier. Now remember the Bayes theorem for spam email classifier. Now this is a theory which describes the probability of an event. If you toss a coin, we don't know if it's going to land on the head or the tail. So we say it's either A or B. So it could be 50-50. The probability is either A or B, but it cannot be both. So that's based on the formula you see. This is very intimidating, but don't worry about it. This is just for illustration, and then some explanation here. If you did statistics, you probably encountered that. this is a huge one. I mean, in almost any betting game, this is something which they do, you know, for prediction. Okay, so this just for illustration again, like we classify the data. I'm just using how they classify those spam mails when they come in. But this is just an illustration. So it's a problem which makes a problem statement. Say we have word 2, word 3, word 4, where word 1, word 2, word 3 is a set of unique words containing the message. Now, when you do spam detection, in a minute here, you'll see the library which we use a lot in doing the natural language classification and processing, okay? And we call it the NLK, okay? So natural language kit. And of course, we have more than one library. Within a library, we have different methods, how they do that. So I'll browse through this real quick so that we don't waste any time on that. Okay, so now when it comes to, hold on guys. Sorry. Now when it comes to email and spam detection, we use natural language toolkit for parsing the messages. This has been called a wonderful tool for teaching and working in computational linguistics using Python, and amazingly does a good job. So for a language, it has to be categorized. We have to clean it up, and you know, for example, you know, certain email coming to you, you know, they're coming from, say, spammers. People who just want to sell you something, or people who are using some catchphrases. Now, this language library should be able to help you process that and be able to identify. So there's a link which I'll share with you, but I introduced the basics here, okay? For example, here, how you have to install it. It's a library. And then once you install it, then you have to import it. And then what we did here, we just tokenize a sentence. We say, let's tokenize that. So we say, this is a sentence, and then once you tokenize, then it breaks it down, okay? Typical example. Yeah, so once we do that, then we go back to probably the same thing over there. Okay, then this is now a whole lot of processing in the background, which I was able to come up with. So we process the message using the NLTK, okay? And then those messages are basically indexed. Once we index them, and then we know the pattern of the wordings which will be coming through, then using your toolkit here, you should be able to block the emails. So here we read, this is a CSV file. We imported it, and then once we uploaded, then we read it. When we read it using the mail.head, we were able to come up with this output, okay? Once the output out there, sorry, out there, and then I'm gonna have to share with you the link so that you can understand it better. But in order, at another slide, I have that summarized, because it comes with how it categorized, use the word cloud, the word cloud, and all that. So it's probably not really something you can get hold of right now. Okay. So going back again to the cleaning of that data, which I think is probably already been touched, so we're gonna skip that. Okay, that one is also the same thing. So the outcome of what we did before, some of this already been repeated. Okay, that's the same data we have. Okay, so I have the visualization of what that code is coming up with, and then these are references. Okay, and then I did a code part of it, which I would like to show you, the word cloud. Okay, when we ran that, it came up with with like basically if you wanted to see what are the most frequently used words in those spam emails. Okay, once you keep them in a text, for example, you can get the description and keep them in such a way that they are all together. Then you can run a library which can basically randomize them and then put them in a cloud like this one. So this is something which, when I ran, it came up with that. And again, I have a link which I'll share with you. Okay. And that's basically it for us for today. I'm so sorry it took a long time. It's very boring, but I hope you enjoyed it. Do we have any questions?
Do you have recordings of the classes you've done before?
I do. I think we can share that with you, yes.
Share in the chat, and I would like to join your WhatsApp group, whichever one it is.
Okay. And your name?
Sue.
Sue?
Mhm.
Okay. I know we have a WhatsApp group, and I know it's pretty full, but if we have a number, then we can keep in mind. So whenever it becomes available, then you'll be added in.
Oh, interesting. Okay.
Feel free to share your email with me so I can, you can have,
Okay.
yes.
Cool.
Any other question? Anybody?
And thank you.
You're welcome, thank you.
Mine is just a comment. I just want to say thank you. Can you hear me?
I can hear you, yes.
Yeah, I just want to say thank you. Thank you for today. This is not necessarily my area, but I was just, curious to come in and just see and learn and everything. So from a layman in Python, just, walking in, I have enjoyed your class. Thank you.
Thank you, Jack. Appreciate you coming. Thank you for your time.
Thank you. Thank you for your time.
Oh, thanks.
When is the next class?
Yeah, this, as you can tell, this class is part 2. Okay.
Yeah.
And then I would like to do part 3. Part 3 will most likely come in within maybe 2 weeks from now, but I'll definitely communicate it, because part 3 will now be talking more or less on the Neo.js, but in collaboration with Python. Okay, so that as soon as I'm ready, I'll announce it, then I'll put it out there. Most likely it could be within 2 weeks or somewhere there, but I always try to make sure that we space them out so we don't interfere with other people also doing some other classes. Okay, any other question?
Thanks.
Thank you.
I wanted to say thank you as well. I'm sorry I joined a little bit late, but it looks like it's a sacrifice to take time out of your day to do this to back to the community. So Elvis Ambaro here saying thank you.
Oh, thank you, sir. We really appreciate you taking your time on a Sunday evening to come and join us. Is that Robert?
No, this
Oh,
is
that was
Elvis.
Elvis.
Elvis, yeah. Thank you, sir. Okay. Any other question? Anybody else?
Yeah, so Elvis, sorry, not Elvis, George, this is Robert.
Hey, Robert.
So thanks again for putting in a lot of effort. I can tell you really did a lot of work on this. So
Thank you, man.
great job. So for your next class, I was just wondering if you can just put some real life example that we can go through in detail so we get an appreciation of AI and ML.
Yeah, that would be
Is
great.
that
Mm-hmm.
like if you take the stock analysis that you I got the impression it was quite detailed. So maybe if you can do, from scratch to end, here is where you start and here are the mechanics of it. And
Yeah,
here's the output. I'm just thinking that would be a wonderful exercise.
that's great, because that's why I was even saying I would like to share some of the links of where I did it step by step. Because one thing I was trying to balance is I don't want to bore you guys, because I mean, if you were to do one example, it probably might take 1 hour.
Which is good. Personally, I think that's much better because then you get the nuts and bolts and it just gives you foundations for the next level up.
Yeah, that's true.
Mm.
So you feel free to reach out. I mean, if you want to reach out, I mean, if we really get maybe a few interested people, then we can have a session whereby we just take one problem and then we do it from A to Z. So
You can count me in.
Okay, that would be great then. Yeah, so we can do that, and then that way we learn. I mean, if you can do one thing, you import all the libraries and you'll be able to see, then of course there'll be numbers. Most of the numbers for like AI or machine learning, they're in the percentage. But the eventual percentage is what we say, okay, if it's 80%, then if we were measuring the predictivity of whether it's going to rain, and it's 80%, then we know it's 80% chance of rain, or 80% chance of for example, getting that spam email come through. So that would be something we can do. And I would love to do that if we can get enough people in there. Maybe after we do this, the next session of Python with me. Okay.
Sounds
Any,
good.
any other
Okay.
question, anybody? Okay. If there's no question, I would like to take this time again to thank you all for joining me. I know it was too long, and I hope you guys enjoyed the basics of what we had to do here, and we look forward to again having this type of session next time, maybe within a week or two. And then hopefully you guys come in and then we close the session. There should be 3. Okay, thank you again. You have a good day.
Thanks, everyone.
Thank you, sir.
Bye.
Goodbye.
Thank you. Bye-bye.
Thank you.
Thank you.
Thank you.